everyone. I'm Lindsay Lewis, editor of Building Enclosure. Thanks for listening along with us today. On October 23rd at 2 p.m. Eastern Time, we have a live webinar airing, Resilient and Adaptive Roof System Design. Our presenters, Matt Braun and Jason Conley, building design managers for GAF, are here today to discuss the webinar. Jason and Matt, thanks for sitting with me.
Hey, thanks for having us, Lindsay.
Thank you, Lindsay.
So to kick off, how do you define resilience in the context of roof system design, and how does it extend beyond basic code compliance?
Yeah, I can take this one. So the ability of the roof system to withstand a wide range of extreme weather events. That's how I think I would define it. Most people think hurricanes and tornadoes when I say extreme weather events, but it also includes things like wildfires and hailstorms. And so, it's important to remember that code is a set of minimum requirements, that standards, that have their own limitations, and designing for resilience looks like, over designing above and beyond those minimum standards from code based on environmental factors and weather trends.
Now, if we're looking closer at the code, what are the primary limitations of current building codes when it comes to ensuring resilience against extreme weather events?
Yeah, I'll jump in on that one. So typically building code lags behind what's happening right now. Building code's updated every 3 years, is a typical cycle. What's happening today with weather is dramatically different than what was possibly happening 3, 6, 9 years ago. We're seeing more and more violent storms, greater convective energy storms occurring throughout the U.S. due to increased heating of the atmosphere. It's creating more violent storms. And so it's taking time for that building code cycle to catch up to those violent convective storms. It will get there eventually, but it just takes time. So building code is a snapshot at that point 3 years ago, and that will get updated based on new climate data that comes in.
Now, in both of your experiences, what strategies most effectively improve wind uplift resistance in roof assemblies?
Yeah, I mean, nothing really beats over design. Whether there's a bunch of attachment styles that you can use for roof systems, but in general, it's using tools like FM RoofNav or Nemo to find rated assemblies. But instead of looking at assemblies that are rated to the minimum standard, it's going 5, 10, 20% over what the code calls for and designing towards that. Beyond that, it's making sure that the securement around the perimeter of the roof membrane is properly designed and properly installed. During high wind events, the area of the roof that fails most often is around the perimeter. And so having edge metal that's rated per the ANSI SPRI standard ES1, and then ensuring during the course of construction that it's installed and attached, to meet the wind uplift design standards or the requirements is key.
Now, if we're shifting the conversation to moisture, what role does robust water management design play in ensuring a roof system remains functional post-storm?
Oh, it's absolutely critical with low slope roofing that we get the water off the roof as quickly as possible. Roof designers, roof consultants, whoever they are, either an architect or a registered roof consultant, is going to sit down with climate data, design for how many drains, depending on the square footage of the roof, how many drains, the sizing of those drains to make sure we get water off that roof as quickly as possible. Water sitting up on the roof, either small ponding areas, but we're more concerned with if there's debris in those drains or if it's not sized properly. Having a tremendous amount of water left up there after the storm is going to create additional dead loading. It's going to overstress that structure, and you could possibly have a roof collapse, which is the worst case scenario. So it's very important not only for looking at resiliency for the roof system to resist that storm and the water that comes out. And we're seeing the rainfall from these greater convective storms falling at a faster rate than what climate data showed 10 years ago. It's only going to push roof designers to increase more drainage, larger drains to get that water off the roof.
So how do you approach integrating rooftop energy generation and storage systems while maintaining overall roof resilience?
Yeah, I can take this one. I'm in Colorado, and so rooftop energy, like solar panel systems, is very popular in this area. But honestly, integrating them into the roof system from a detailing perspective is very similar to any other penetration. You're either going to be flashing into the roof system if it's mechanically attached or supported, or you may hold it onto the roof system with a ballast system. But some of the systems can be quite heavy, and so making sure you utilize a structural engineer to make sure that the added weight from that solar panel system or energy system can be handled by the roof system. But it's also really important to be forward thinking with the design, especially when it comes to the timeline or lifespan of both the energy system or solar panel system and the roof system. That's why it's really important to line up the lease timeline for most solar panel systems. That's how most people utilize them, with the warranty period of the roof system. So you're not trying to repair anything or do anything out of timeline and do double work and double cost.
So will you guys be sharing any specific project examples during the presentation?
Yeah, absolutely. I mean, I can share one right now that project that was re-roofed back in 2023, the Savannah Convention Center in Savannah, Georgia. For those who might not know here on this podcast, Savannah sits right off the coast of the Atlantic, is definitely exposed to tremendous wind uplift during tropical storm hurricane force winds. The designer for that project wanted to make sure that that building will be resilient through high wind uplift events. They made sure that the system, working with the roofing manufacturer, was going to be robust and resilient. And they added a high compressive strength gypsum board behind an adhered single ply membrane. The high compressive strength gypsum cover board creates a stronger diaphragm. It keeps the membrane adhered during very high wind uplift events. Not building code required per se, but it's something that's added in addition to the roof assembly to provide that high wind uplift resistance.
Now, looking ahead, what innovations in materials or policy do you anticipate will possibly most impact resilient roof design?
Well, hopefully, from a policy perspective, we see more widespread adoption of more current codes and incentive programs that encourage people to build more resilient buildings. But honestly, the advent of AI has really changed the game when it comes to data-driven research and modeling, especially with weather trends. And then also evaluation of roof systems following, these major weather events that can detect, the structural integrity of the building and the roof following the storm, but also detect any, minor issues that may cause leaks or may cause more catastrophic issues down the road.
Now, I know we already went over a lot, but lastly, I do want to ask, what else will attendees learn during the webinar?
They'll probably pick up all kinds of items and topics based on low slope roofing. We get lots of questions during these webinars that might seem like they're coming out of left field or right field. And they're great. Matt and I love it. We live in this world of low slope roofing. We're probably going to touch base on why this single ply membrane. Why would you use that insulation? Why this? Why that for resilient roofing systems? Bring those questions with you because it's going to run A to Z and we just love it.
Well, thank you both again for your time today.
Thanks, Lindsay.
Thank you, Lindsay. We appreciate it.
To register for this free webinar, head to continueducation.bmpmedia.com. Until next time, visit us at buildingenclosureonline.com for your technical and educational resources.